wonder about something. Something not important to me personally, but important to my understanding of the world and its various criteria and schema. I was watching an article on a very developed form of the F-15 jet fighter plane. This one has an extra pair of wings called canards at the front. So there are these canards about where the pilot is sticking out, and then there are the regular wings, and then there's the tail. So that's three sets of wings. It also has three-dimensional vectoring jet engines. So each of the jet engines on this F-15, the nozzle on it can rotate, right? Point different directions, in, out, up, down. That can help very much, especially in certain very low speed moments when you're landing, when you're taking off. Times when your wings and your control surfaces are not providing as much control as you really need for an aircraft that big and that unstable. And that brings me to something very confusing as far as I'm concerned. The idea is that they mount the engines, the two engines on an F-15, as close together as possible. Now, it makes sense from one point of view, at least as it's explained to me. This is how I thought I understood. Two engines together rather than widely separated means less chance of this from uneven engine thrust, yaw, right? Because one isn't slightly more powerful when you have the throttle set at a certain point, and one isn't slightly less powerful, so the plane wants to always turn and you have to trim it. So you put the engines close together, and the thrust is on the center line. As a matter of fact, the British did it with one of their experimental planes where they had the engines one over the other, which was kind of neat, right? So that if there is any problem with stability, it wouldn't be yawing from left to right because the engines were in line with the center line of the fuselage. It would be pitching up and down because the engine on top, if it was blowing harder, would make the plane want to dip down. If the engine on the bottom was blowing harder, it would make the plane slightly more want to tip up. Then you trim it. But this led me to some tangential facts. In World War II, the Italians, who had a very advanced armaments industry, but it was a small one, so it was strapped for materials and strapped for production facilities, so it didn't make a lot of something. But the ones it made, it tried to make the very best it could. And out of all the things that the Italians made in World War II and the World War II era, its navy got the best of it. Because Italy, what is Italy? It's a giant seacoast, right, with mountains in the middle. The Italians liked to put their multiple guns and the turret of a cruiser or a battleship, the big ships, close together. Okay. That leaves you more room on the outsides of the guns inside the turret so that you can work those guns. Men can get around them, men can squeeze in, and men can do things and fix and maintain. And it makes it cheaper to operate. It makes it, well, it improves ergonomic efficiency if the design takes advantage of it. Other nations might put their guns very close together, like the British did in some cases with their destroyers. Their two turrets the turrets are wide, and the guns together are very narrowly spaced. If you look at America in World War II, you will see that that was the opposite. Our 5-inch gun turrets were very widely spaced. The guns weren't together, they were widely spaced. Now, if you look at the 1980s and 90s, the Russian Kirov class, and I think the Slava class as well, these were modern warships, one nuclear powered, the other conventionally powered. They were very large warships. If you look at them, their 130 millimeter guns are also very close together. But I want to focus, I just gave you as much information as I could, I'm sorry, I like to explain. But I want to focus specifically on the Italian guns in World War II, the ones I was mentioning first in this small diversion. Those Italian guns were known for being inaccurate. And the reason given is because the guns being so close to each other in the turret interfered with one another when they fired together. So each gun creates this big ball of expanding gas. When you hit the primer in the powder bag, which is just like the old cannons, really. When you do that, that powder burns, and why the reason that gunpowder has a propelling charge, why it can propel things, is because that solid matter in that bag suddenly turns into 9 cubic feet of gas for each period on a sentence size grain of powder there is in there. So it instantly or very rapidly creates this enormous ball of gas. There's nowhere for it to go. The breech is very heavily constructed and sealed. It's obturated. That means it's sealed off. And so that huge ball of gas pushes, and takes a path of least resistance. It pushes that artillery shell, that round, that penetrator, whatever it is, through the barrel and out the barrel. Bang, there goes the projectile. When it does, as the projectile leaves the barrel, all that enormous amount of super compressed gas, because it wants to expand, like I said, to this huge area, then expands to a huge area. That's what that giant ball of orange flame is when you see a gun being fired, a cannon that large being fired, or even a rifle fired. That's what the flame on a rifle is all that gas inside that tiny little bullet gets produced, pushes the bullet out, and then whew, it expands. So if you're standing next to a rifle when it fires, you'll feel a blast of air in your face, because that's that expanding gas pushing out as soon as the projectile leaves the muzzle, uncaps it, kind of like a champagne bottle. You uncapped it, and poof, all the gas inside expands out in every direction it can. So these Italian guns are known to be inaccurate. The Italian 6-inch, the Italian 15-inch. These are, doesn't matter to anybody but naval men. But the point being, these guns were so close together that when they were fired together, the burst of gas coming from this gun and the burst of gas coming from that gun would create turbulence that would tend to push the rounds emerging from the barrel off their trajectory. And so the Italian guns were known to be extremely inaccurate. Now, I haven't read about or heard about that problem afflicting the British, who also did that, so I don't know why. I would guess that's because they slightly offset the timing, and the guns don't fire together, so they don't mutually interfere. Whereas in World War II, that wasn't as well understood. That is a possible solution vector. I could be wrong. This is just my guess on the topic. But the point being, the official narrative says that those Italian guns were inaccurate because they were so close together that they interfered with one another when they were fired together. All right. I'm going to take that as my point of departure. If anybody out there knows more about this, I'd be glad to hear from you. So what happens when you take that expansion by combustion, right? You expand the propellant into a large volume of gas inside a jet engine too. A rocket engine or a jet engine is just a very slow explosion. The energy density of the fuels is pretty high, almost equivalent to explosives. But they don't burn all at once. Whoomp. They burn from vapor pressure. They are aerated, they are formed into a mist, and that mist is intensely combustible. But until then, they're about like kerosene. Kerosene can be burned, and it does burn, but it generally burns on the top, and what's burning away is the gas being formed as it evaporates. The body of the kerosene doesn't want to suddenly blow. There's American history that I'm not going to refer to here that's probably valuable for this discussion, but I'm going to leave it out. So, what we have here in these jet engines being placed very close together is essentially the same thing we had in those Italian guns placed very close together. So my question, the question that I wonder in my mind is, do the engines on an F-15 or an F-18, which is the Navy's twin-engined general purpose multi-role fighter, Do those engines being spaced so close together inside the fuselage interfere with one another? Are they aerodynamically inefficient? Are the aerospikes, the the gas pressure cones that you see coming out the back, that's what rocket exhaust is that expanding gas. Are those, which are really blasts of wind? I mean, if you stand next to a jet engine or in back of a jet engine, you can be knocked over just from the force of the exhaust. So are they interfering with one another? Does that aircraft lose stability? Does it waste a huge amount of energy from each engine interfering with the other engine's exhaust? That was my question. The older you get, the more it pays to try to make your mind work. It may not happen, and you may be frustrated at it, but it's as good a form of exercise as any, I think, for maintaining activity as late into life as one can, while